Let's do one. Here's a straightforward one. Kind of the game. Solve the triangle. Cool? 3 pieces of information. Let's go to a triangle. I got just some randomly just drawn up one. Are you going to make your triangles exact every time? You're going to get your protractor out? You know what I mean? You're going to get your ruler. You're just going to draw a triangle. See, me, I typically just draw a triangle. I don't really trip about it, so that's what I've done here. This is not the scale. I like putting the A down here, B right there, and then C over here, and then I line it up. So I'm like, okay, still looking for A, B's over there, so C's over here, and then this is going to be 60 degrees. All right, sweet. Now, how you're going to need to be able to solve these problems is not necessarily being told, use the law of cosines to do this, or use the law of sines. If you look, as I said before, I try and default. If I find an angle and there's 2 sides, I'm like, oh, do I have another? Shoot, I don't. I'm looking for that ratio to set up for the law of sines. Since it's not there, it tells me, oh, I'm probably hanging out at side, angle, side. And that's what's happening, side, angle, side. And it doesn't have to be in this bottom left corner. I just try and keep it in that direction. We'll see in some other examples. So what this is going to do is it tells us we should be going to get B. Right? That's side opposite the angle, which tells us let's use this formula here. So let's set it up. Let's just write it out and we'll start filling stuff in. So we'll say B squared is equal to A squared plus C squared minus 2 times A times C times cosine of B. So let's pop all that stuff in. Our A is equal to 3, so let's put the A in there. Our C is equal to 2, so we'll put our 2's in there. And our B, that's 60 degrees. This one turns out actually super clean because I gave it a 60 degree, but typically they won't. So now you just clean it up. You got a calculator, don't you? Use it. Or maybe you're a weirdo like me that likes to go, well, that's going to be 13. 2 times 3 is 6. 6 times 2 is a 12-pack of beer. Times cosine of 60. And you would put this in a calculator. It just happens to be that this one might clean up pretty nice. But, oh, we're solving for B. We need to hit it with a square root. Now, we don't need to really stress out too much about the plus or the minus because, well, we're dealing with lengths. I don't know about you, but I'm not negative 6 feet tall. So I'm yanking out the calculator. You could have done it right at the beginning. However it is you want to clean it up, I like to do a little bit of arithmetic to it first. Go through, double check all my stuff, and I find that the B is approximately 2.65. So let's replace 2.65. Now that we have that ratio, now that we have this, now I'd like to go back to the law of sines. At this point, you do not need to go back to the law of sines. You can use the law of cosines the whole way through and solve for angles at this point. You may do that. I'm going to go back to the direction that I like. I go to the law of sines. But there's some danger in using the law of sines here. Since we have that given ratio, or it's not given, found now, so sine of 60 over that 2.65, we can now set this equal to any one of the ratios we want. However, there's a certain one that I'm always going to go for. I won't go for A. I won't go for A. I'll go for C instead. And the reason is, it's this one real big piece I was trying to stress last time. Oops. I'm going to write it up in the right-hand corner. Sine inverse doesn't understand angles over 90. It just doesn't. So only one angle in a triangle can be over 90 degrees. So look, we have our smallest side is 2, our middle side is 2.65, and our largest side is 3. The only angle that is possible of having an angle over 90 degrees is A. And in this case, there's no issue. None of the angles are over 90 degrees. But one way we can make sure that we never have to do that, we never have to even trip about it, is when using the law of sines, I always go after the angle that's smallest. S and S. Law of sines with the smallest of the angles. This ensures, since only one of the angles can be larger than 90 degrees, the smaller one can't. It's impossible. It has to be smaller than 60 degrees, since 2.65 is opposite 60 degrees. It's small. No issue. And we put it over the 2. We go through and we solve. We get 2 times sine of 60 over 2.65 is equal to sine of c. The way we get that angle out of the argument is we hit it with an inverse on both sides. And what are we going to pop out of this? We're going to say that c is approximately equal to, oh, there it is, 40.8 degrees. And I'm just going to round the angles to 1. This is actually my commonplace, so it'll go back and forth. I'm just doing this 1 to 1. So sorry if, just make sure to always read what the instructions are and where they want you to round. So there's your 40.8, and now you're left with the simplest of things to do, and that's to calculate 180 minus 60 minus 40.8, because that's going to go get you your solution. So let's see, A is equal to 180 minus 60 minus 40.8, and A is equal to, that's, what is that again? 79.2 degrees. 79.2 degrees. And we've solved the triangle. And the next one, I'm going to throw a trick at you, and we'll solve another one. See ya.